Alright, so this is going to be our notes on the kinetic theory of matter. And we've been talking about things like the phases of matter. And kind of a little bit we've been talking about, well, what makes something like we see here a solid or a gas. We don't have liquid here, but we could add that in there. And see if I can draw this. Alright. So a liquid too, we could add that. We could even add something called plasma, which is the next step beyond a gas. And you can imagine, as we're going to learn here, what causes something to change from a solid, a liquid, and a gas, what the next step would be, plasma, and what would result. We'll talk about that in a minute. But there's an idea that scientists use, or a theory that they use to talk about why some matter exists as a solid, some as a liquid, and some as a gas, and why they change, and what are some of the properties we can observe when they do. So the general idea of this is that matter consists of separate individual particles in continuous motion. So like if you have H2O, say you have water vapor, you have actually need to erase that, just clear this whole thing. And so if you have an oxygen, and we have two hydrogens, right? And then if we were going to denote this with a black circle, then we were going to say we had a chamber that had particles in it. Probably made them a little bit smaller, but we'll just go with this. Okay. So, and then depending on what it is, these are going to be in continuous motion. So this might be going this way, this might be going this way, this might be going this way, and so on, all different directions. Okay, and a gas really separated apart. Solid, very, very close together. So they're moving, but they're not moving very fast. So if we were going to compare, if we said a solid, we'd probably be looking at, very, very close together. So there's not a lot of room for movement here. This would be your solid, And then if a liquid, we'd probably be a little bit further apart. Not great distance, but far enough apart so there is some movement. Okay. Like that, and then we have this gas that's really spread out. Okay, and particles are in constant motion. If they're not constantly moving, that means they have no energy, and that's something that really, in the universe, in the grand scheme of things, can't really be possible. Something's either something has to have energy to be matter, and we'll kind of talk about that later. But so this motion, we can understand, like we just said, solids, they're the slowest. And the reason they're the slowest is because they're the closest together. Okay, and the reason the gases are the fastest, they're spread apart the most. Now, that's misleading somewhat. We'll talk about that in a minute. Okay. But because this fast motion, it causes them to spread out. But there's something actually that causes all this. Okay, and that is energy. And we've kind of learned about energy and its ability to do work. And so, depending on the substance, if you give it energy, if you give it enough energy, it'll cause it to change state from whatever it is. So if you have a solid, like maybe a good example is if you're cooking something at home, okay, and let's say you want to melt some butter in here. So you put some butter in the pot, and you apply energy to it, heat, with a propane stove or whatever, okay, and so you heat this, and you cause these particles that are closely together to become more spread out because you give them more energy to move. If you give them enough energy, then they start getting further and further apart. The thing that keeps them together are these intermolecular forces, and it takes some energy to overcome them. So depending on the substance, then you have to give it more and more energy to get them to separate further apart, form a liquid, give it more energy, form a gas. Okay. Now also it's important with these particles that it doesn't have to be a single particle like oxygen. And oxygen actually exists, if you remember. It's a double bond, right? So there's two oxygens. So oxygen gas kind of looks like this. It has some electrons, right? We've drawn these. Okay, that's oxygen N2. But it can also be H2O like we drew, but it can also be a combination. So you can have water vapor H2O, you can have nitrogen, you can have oxygen, you can have CO2 all mixed within a parcel of air, and those also move the same way. Okay, so yeah, so the air can be somewhere like a gas or a liquid and so on, okay, depending on how much energy it has and what's in the air. Okay, so and like I kind of hinted here, so if we want to increase this motion, this continuous motion, then we increase energy. So we just kind of heat it up or whatever it takes to get that give those particles more energy, and then they start to move. Now energy can be transferred in a lot of different ways. I'm going to erase this, and we'll kind of hint at it today. But there's really three main ways that energy is transferred. One way is direct touch. That's called conduction. So conduction. Okay. This is a really good example. Maybe you don't know this. I kind of assume people know this, but a blacksmith. So a blacksmith used to, we don't have them anymore, but they used to take like a piece of iron and they'd put it in the fire and heat it up, and then they would bend it. Okay. Well, they heat that metal up, and it causes those particles to move faster and faster and faster, and then they could eventually, if they wanted to, they could cause that solid to turn into a liquid. Okay, so and how that works is you have this fire that has heat or energy, and you touch directly to it, and the molecules then transfer down the substance. So if we had a piece of metal, okay, and we took a torch and we heated it up with some fire, right? So we'll make this yellow or orange or something. Make it bigger. So if we were heating this up with a torch, right? And it would initially get hot right here, right? And you've kind of probably noticed this when you heat things. It gets hot here, but then as it meets other molecules, it starts to go further and further down and spreads to the whole entire thing. So if you were heating this here, eventually this section up here would get hot because the molecules pass on that energy. That's conduction. Another way is radiation, and radiation is just through waves like sunlight and other types of waves. That's another way to transfer energy. And the final way is through convection, where you cause an air current difference in density of a substance, whether it's a liquid or a gas, just really a fluid, then it can transfer air that way due to the unequal densities, and the less dense object rises, and it transfers that heat that way. So those are the three main ways: conduction, convection, and radiation. Okay. So let's go erase this now. And so if we want to increase the motion and change something from a solid to a liquid to a gas, we increase energy. So really, when we look at this, it's all about energy. How much energy are you putting into something? If you can put enough into it, you can cause it to change state. Okay, so if we are then going to look at these states, the phases, and really describe them, solids and liquids are not that different. Okay, they're closer together. What's holding them closer together are those intermolecular forces. And the two main forces we think of are the nucleus and the electron cloud. Okay, they hold, they have attractions. The nucleus would be positive, the electron cloud is negative, and those opposites attracting can hold molecules together. But there's also another one called hydrogen bonds. So we'll make this red. And this one really, if you know anything about DNA, it's what holds DNA together. And a good example of this is oxygen, or H2O. So you have hydrogen, and it's attracted to oxygen. These are covalent compounds. They share electrons. So let's make them pink. So they're each sharing electrons, one of each, right? And that helps them meet that octet rule. Then oxygen would have 1, 2, 3, 4, and that's a nice compound, right? But if you remember correctly, this is a covalent compound, but it's polar, and what happens is these electrons get pulled a little closer to oxygen. So they're still really sharing them, but they're just a little bit closer to oxygen. So since it loses this, it becomes a positive region in the molecule, and this becomes negative. Okay, so this hydrogen bonding with oxygen causes it to have a charge, and then any molecule that has this this kind of nature, it has an extra force that it can hold things together with, and that's kind of what happens here. And there's some other types too, we're not going to really talk about this today. Okay, but so these resist coming apart through hydrogen bonds, through intermolecular forces, all those kind of things. So because of that, because they're so close together, there's little compressibility. So you can't really push them together because they're already together. Water, if you've ever taken a syringe, you can compress it a little bit, but not a lot. But then you take a gas, you can really see it. So if you just fill up a syringe with air, you can see it's really compressible. So this is very little compressibility. It's hard to push these molecules together because they're already close together. And then we look at gases, though, they're further apart. And really, because they're so far apart, these intermolecular forces, they don't matter. They're not strong enough to overcome the energy you've given it. So as a result, they're very far apart. And as a result, you can then push them together. They're very compressible. Okay, so, and we're going to look in a lab. So what happens when we do that? So if I had like a container, like this, okay, and I had a gas. Let's just say it's, we'll just call this N2. So I had this, all these particles moving around. Okay, we're going to do a little sim on this, so it'll probably help you understand a little better. So if these are all particles that I have, and they're all moving in different directions, maybe that one's moving that way, this one's moving that way. I'm not going to label them all, but you kind of get the idea. Okay, and these are elastic as well. These collisions they have, they don't lose energy. So they hits this wall, bounces off that way. Energy is not really transferred. Okay, but if I could somehow take a piston and put it in here, okay, and then push this piston down, I could have the ability to compress this gas. So if I was going to, let's see, so if I push this, I could take this container and make it this size. Okay, so you can imagine all those particles are now closer together. Okay, but they have the same amount of energy that you started with, and so that's going to tell you. You might think about, well, what's that going to cause to this cylinder here? And we're going to do a lab on that. Okay, but these are compressible. See, you got all this open space here. If I was going to highlight this with yellow, this is all open space right here. You could just squish all this stuff, and this could all these particles could then be pushed together and make it a tighter formation like this. And that's a really big property of gases. They're compressible. So that's kind of the notes for that. Hope that helps you understand this a little bit better. Let me know if you have any questions.